to deliver a session on additive manufacturing. First of all, let me congratulate Sir Dr. M.S. Gosavi Polytechnic for organizing this FDP on a very emerging technology.
Wakchaure sir, hello.
आवाज येतोय?
Let me introduce yourself. Then,
Okay, please.
ठीक. Sir, करू sir.
Yeah, please.
Good morning, one and all present here. It gives me an immense pleasure to welcome you all, curious knowledge seeker, to this three-day faculty development program. I am Professor Amit Satgir from Sir Dr. M.S. Goswami Polytechnic Institute, Nasik Road. And I extend a very warm welcome on behalf of the Department of Mechanical Engineering. The first session of the three-day faculty development program on additive manufacturing and 3D printing is graced by a very distinguished personality. So I take the honor to introduce our keynote speaker, Dr. Vishnu D. Wakchaure sir. Professor Wakchaure sir is currently serving as the head of Department Mechanical Engineering at Amrutwaini College of Engineering, Sangamner. Wakchaure sir's profile maintain a very bright academic records. He has completed a bachelor degree in mechanical engineering and has earned master degree in CAD/CAM. He has accomplished a PhD in engineering. Moreover, sir has completed MBA in material and logistics, and he has been pursuing a PhD in management from Savitribai Phule Pune University. Wakchaure sir has 30-year long experience in academic and industrial sectors. Sir has designated many reputed positions in
आवाज गेला
responsibilities
आवाज
efficiently.
कंटिन्यू
Wakchaure sir Wakchaure sir has achieved various prestigious awards and recognition from several institutes, organizations, government agencies, and Savitribai Phule Pune University. Wakchaure sir has done a remarkable work in the field of research. He has been approved as a PG teacher since 2007 and PhD guide in mechanical and production engineering. Sir is a member of Research and Recognition Committee, Savitribai Phule Pune University. Under his guidance, a total amount of rupees 65 lakh 39,000 has been received in the form of grant from a number of projects and research work sanctioned by the government. This session will explore overview of additive manufacturing, evolution of 3D printing technology, and comparison with traditional manufacturing. I warmly welcome Dr. Vishnu Vaksaure sir and request him to share his insight with all of us. I hand over this session to Vaksaure sir. Sir, please continue.
Okay, thank you very much, Professor Satgir. So,
Thank you, sir.
thanks for inviting me to be a part of this particular FDP, and congratulate you for organizing this kind of FDP on the emerging technology. As we know that this particular FDP for 3 days, and I will be having an opportunity to take this particular opening. I'll be dialing, right? So all these particular topics related to additive manufacturing, right? From what it is to the emerging technologies like its application in biomedical engineering and likewise. Over a period of these 3 days, all these particular sessions will be touching upon these particular aspects of additive manufacturing.
Wakchaure sir, please
Wakchaure
So
sir,
share your
please
let
share
me.
screen.
your screen.
Sir, please
Sir,
share your
please
Uh,
share
screen.
your screen.
I think this screen is shared. Just one sec.
Not visible,
Not
sir.
visible,
Please
sir. Please
reshare your
reshare
screen.
your screen.
Just one sec. One sec. Is it visible now? Hello.
No, sir.
No, sir.
No,
Presentation
sir.
No, sir.
visible?
No, sir.
No, sir.
No. Just one sec.
नहीं झालीच नाही कधीच.
एक मिनिट.
नाही. Pradeep Deshmukh sir, please
Pradeep
turn off
Deshmukh
your
sir, please
camera.
turn off your.
बघा कसं लावून धरलं. चार्ज तर काय काय
फोन करू का
करतील का करतील का हे ऑनलाईनला आहे इश्यूज. येस प्रेस कोण
प्रेस फोन करेल त्यांना पुढं वाक करायचं असेल परत ते. बरं बरं चालेल चालेल सर करा करा. हो 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 सांगा 2 मिनटं सांगा सर. डेस्कटॉपला ते लॅपटॉपला कनेक्ट करते चालेल.
I request all
I
participants
request
to
all
be present.
participants to be present.
Due to some technical
Due
errors,
to
you
some
need to
technical
wait for
errors,
some
you
time.
need to wait for some time.
डेस्कटॉपला काहीतरी इश्यू होतो.
Sir, is the screen visible now?
Yes, sir.
Presentation?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, fine. Thank you. Fine. So actually, now I will be covering the overall aspects of additive manufacturing, wherein I will talk about the 3D printing, right? What is the basic principle? I will be comparing the subtractive manufacturing with additive manufacturing, why it is required, and why this particular 3D printing is a disruptive technology. Please forgive me, I will be using this 3D printing and additive manufacturing alternatively because they are one and same, right? And how this particular 3D printing takes up we people closer to the nature, which is basically a manufacturing process of nature. I will be talking on benefits and applications, some of the limitations or the constraints, right, which actually are restraining this particular 3D printing, and the proper care has to be taken in that regard. Then rapid manufacturing and allied technologies, right? So I think through this particular presentation I will be able to give a overall idea, right? Though Zakri sir has shared a few important aspects related to 3D printing, I will be taking you too much details, right? So I hope that at the end of session, you will be able to understand what 3D printing is, what are the different methods, applications, and what more can be done as far as 3D printing is concerned. So let us begin. So here, let us begin with the prayer of Lord Ganesha for the whole FDP, and whatever the pictures are being portrayed here, you can see it is a typical example of a additive manufacturing or 3D printing, right? So you can see here that the idol of Lord Ganesha has uh, being prepared by adding layers one over another, and that's what the 3D printing is, right? So let it be any material. It could be plastic or metal, or in this case the jute is used. In another case we have a sand, and likewise, right? So whatever is the material, if we go on, right, simply putting additive manufacturing, we go on adding the material layer by layer over one another in order to get the required product, right? So that is the simple meaning of additive manufacturing or 3D printing, right? So why it is 3D printing is, whatever the conventional printing on the paper we have, it is 2D printing, right? So we print on a paper which has got X and Y axis, right? In 3D we give that particular Z, fine, which provides you the what do you call third dimension, right, in order to make you solid, right? So that's what is the additive manufacturing, right? So if you compare, look at the traditional method, basically it has got some machine tool, and the operator will be in the form of a human being. So there had been a lot of human interactions are required. The individual components are manufactured using conventional machine tools and toolings. Then we have the assembly of all these particular components in order to get the required product. So as a result of all these things, right, so what we require is, we require more money, the manufacturing cost is very high, we require more time, and thus overall the productivity of the manufacturing system goes on decreasing, right? So in order to avoid all these things, right, so this is what basically called as the traditional methods are called as subtractive manufacturing processes. If we categorize all these manufacturing process, we can see that there are chip removal process, there are some forming process, casting, forging, and like that. We have some welding and joining processes, right? So all these particular processes, if particularly if you look at the chip forming processes, those are subtractive manufacturing processes, right? Subtractive means what we do have, we have a particular raw material in the form of blank or likewise, and then we remove the unnecessary material by removing that unnecessary material in the form of chips, right? So that when we will be able to remove that unnecessary material from the job material, right, parent material, we will be getting the components of required shape and size, right? So basically we subtract the material, right, from the parent material. So why they are called as subtractive processes, right? And another one is what we are going to deal with is additive manufacturing, right? So what we do is we go on adding the material, right? So traditional methods are based on removing the additional material in the form of chips. We subtract those particular chips from the parent material, and in additive manufacturing, we go on adding the material, right? So here you can see that subtractive manufacturing, here on the left hand you can see the CNC machine, right? So in this case are either conventional machines, right? So basically what we do is we have a material subtraction, and we used to get those particular components, right? So now the things has been changed, right? So what we are looking for, as we have discussed, right? So the productivity, it could be a material productivity, labor productivity, or overall productivity of manufacturing system, that is very less in case of conventional, right? And more important is time, right? Nowadays the time to market, and all the cost associated, right? And the future of that particular product will depend on the time. So what we need to do is we have to focus on how we can reduce that particular time of manufacturing, time of product development, time of launch, and how quickly it can reach to the customer, right? So here we are looking for the total automation in the form of art to part, right? Means what we do is the conventional is product design, then prototyping, then testing that prototyping, testing your manufacturing systems, your product, and then launch, right? So the whole development cycle was a bigger one, and in order to reduce that, what we need to do is we have to focus on if we have the CAD systems, right? So if we directly build that particular product in the CAD using CAD tools, and directly we are able to manufacture without human intervention and the requirement for what you call post processing, assembly, and all these things, right? So it will drastically reduce the time required and thereby cost, right? So all the time requires is for resources, and resources as the cost, right? So what we are trying to do is we are trying to convert the art to part, right? So that is from design to manufacturing, or virtual to physical, right? So whatever the CAD model we have, using different softwares, we prepare that particular component or that particular product, and directly we are using it to as that to print that particular product, right? So this is also called as, I will dwell on that later on, various names are there. So rapid prototyping is also another name, right? So it is the old name which was used for additive manufacturing or 3D printing, right? Because earlier this particular technology was used only for preparing the prototypes, right? So rapid is because again the conventional prototyping methods you have to look into, and here directly we will be able to print or get that particular product with the help of additive manufacturing, and so by it was called as rapid prototyping, right? So this is basically a sign change in manufacturing, right? So from minus to plus, right? So if you look at this particular machines, right? So a CNC machine and additive manufacturing on the right side, the basic things are same, right? In CNC we will have XYZ axis, right? Depending on the type of CNC machine, right? We will have drives, we have control system, right? We will have a tooling. Okay, so similarly on the right hand side you can see additive manufacturing machine, right? So it is same, only the way of right, in the CNC machine we will be using the cutting tools, and likewise where in case of AM machine we will be using some mechanism, right? That mechanism which has to be used will depend on the type of or the process used for additive manufacturing, right? But the technology remains same, right? Here what we have to do is we have to control that particular tool. That's what the CNC is doing, right? And here the change in tool is the important aspects that need to be considered, right? So here in case of conventional CNC machines, we will be using the cutting tools, right? Whereas in case of say AM machine, we will be using nozzle if it is a plastic related, or we will be using some heating resource like a laser or like that in case of metal, and likewise, right? So basically there is in change in tool because change in manufacturing process, right? So this is basically the difference between subtractive manufacturing and additive manufacturing, right? So here you can see starting material is a block, or what we call as a raw material. We will be using some machining tool in order to remove the additional material in the form of chips, and we will have final product, right? In case of additive manufacturing, we will have a raw material, right? So this basically additive manufacturing depicts for a 3D printing, right? So generally is not a hard line, but 3D printing we use when we use basically plastic material as a material for printing, right? So here you can see we have a plastic spool, material spool, right, which is passed through the nozzle. We will have here you can see we will have a nozzle. Herein we will have a heater, and the plastic material will be fused, and layer by layer it will be printed, right? So the important point that we need to focus here is, say, if you look at final product plus waste material, right? So here in case of the additive manufacturing, here you can see that the material productivity is very high, because if you look at the waste material which is generated in subtractive manufacturing and the waste material which is in additive manufacturing, right? So the material wastage is very minimal in case of additive manufacturing, and thereby to be specific, the material productivity will improve to a larger extent, right? So I hope that you have understood the subtractive manufacturing and the difference between subtractive and additive, right? So subtractive is from minus type of manufacturing, where in additive we use a plus sign, right, wherein the material is being continuously added in the required form and size. Okay, so if you have to define this particular additive manufacturing or 3D printing, right? So what it is basically a process of joining materials, right, to make the object from 3D model data. Okay, so as mentioned earlier, we need to control the deposition of that particular metal layer by layer, and so why depending on the required shape and size, we have to control the movement of the tool, and that movement of tool, right, as in case of CNC machine, right, we require a CNC program in order to control the movement of a tool. Similarly here, in case of 3D printing also, we need to control the movement of a tool, and in case of CNC machine, we use some CAM softwares, like for example Mastercam or likewise, in order to generate the CNC part program. Here we will be using the STL files in order to control the movement of tool, right? So basically what this ASTM defines the additive manufacturing is that we have to make the objects from 3D model data, usually layer upon layer. That's what is the additive manufacturing, as opposed to subtractive manufacturing technologies, right? So here in case of additive manufacturing, right, so what we do is we go on we use this 3D model, the data generated through the 3D model, in order to control the tool, right? So you will have a session on modeling, slicing, and how to use that particular data for the actual preparation, right, of this particular 3D model, right? So this is what basically means the additive manufacturing as per the EASTM. Okay, so to keep the things very simple, right? So what the synonymous of the additive manufacturing is the process of jalebi making, right? So yeah, in jalebi, what we have a what you call, right? We have a bat of the wheat and all these things, right? It is in the fused state, right? We use a cloth that is put in that particular cloth. We have a small hole, right, and we press on, so that that particular bat comes through. That is kind of an extrusion process, right? So we press it, and depending on the shape and size what is required, we go on adding the material there, right? So this jalebi making is similar to that of 3D printing. You take another example of, say, mehendi, right? So what we have a mehendi in a cone, right? We control that particular mehendi cone in order to get it printed, right, on uh, that particular portion of a part of the body, right? And we go on adding the thickness, right? So depending on the density and all these things, right? So these are very natural processes which depicts the principle of additive manufacturing, right? So hope I'm audible. Everything is going on fine, right, Milind sir?
Yes, sir. Yes, sir.
Okay, fine. Right, so this is what actually I was sharing initially, right? So the conventional printing is a 2D printing, which is again a kind of a lithography, right? So what we have, whether it is a black white print or the color print, and likewise depending on, you will have a printer. You know, if it is color, you will have a CMYK, and likewise, right? And it prints on the plain paper which has got XY, right? Whereas in case of 3D printing, right, which is also in plastic, right? So we will look for afterwards, right? It is also called as a stereolithography. So what the printers are saying, only thing is, instead of XY, here we are adding the Z, right? The thickness and details in the Z direction, so that we are able to print that particular product, right? And so why the additive manufacturing has revolutionized the way the products are designed and manufactured. And at the end also, we will look into what is the market size of this particular AM, right? Nowadays, the customization, right, of the products is on rampage, and because of that, instead of having all the conventional manufacturing systems and processes, the 3D printing is on a large scale is replacing our conventional manufacturing, right? So I think both these particular analogies provide you basically what the 3D printing is. Okay, so as in the beginning we have said, right, whenever a human being is involved in the processes, the system gets diluted, right, for one or another reason, right? So all these particular manufacturing processes, what we do have is, we are looking for automation. It could be a hard automation or a flexible automation, or called as a soft automation, right? So in hard automation, we use the automats. Okay. Then we have special purpose machines. When all these automats are connected together, it becomes a transfer line, and the at the one end material comes in, at the another end of the transfer line material is produced, and in between we have all the mechanized systems, right? And in case of a flexible automation, right, flexible automation is because when the product will change, the type of automation change, right? So the various elements, it consists of the flexible system, right, or the soft automation consists of CNC machines, robots, AGVs, automated storage and retrieval system, right? And when all this comes together, it is basically called as FMS, right? Flexible manufacturing system. So in order to have this, right, so another important part is uh, process, uh, process planning, right? So we have different tools available, like computer aided process planning, right? And again, there are more number of details to it, right? So what basically had happened is, this particular manufacturing systems has evolved from conventional manufacturing to automation, so hard automation, soft automation, and now we are talking about additive manufacturing, right? So here, all these things are probably not required, or are taken care automatically. Okay, so another aspect, as far as the additive manufacturing or 3D printing is concerned, uh, this 3D printing is inspired by nature, right? So here you can see on the left hand side, we have one right kind of uh, a product which is made of the bamboo, and is wound with the ropes and all these things, right? So here basically what we do is, here we have all this particular assembly process, right? This particular bamboo stool is the assembly process. All the materials are prepared separately, and they are taken together in order to have that particular product, right? But if you look at the nature, right, so nature is not a the process is not a assembly process, right? So here you cannot see the wings are manufactured separately, the nose, eyes, and all these things, right? So what it is the whole product at a time, as an integral product, right? Is manufactured, right? Or is not man is right, is given birth likewise, right? So assembly is not a natural process, right? So what it does is, basically the nature uh, prepares that particular product as a single product, as an individual product, because the systems are interlinked and interwoven, right? So basically, the natural process of manufacture, the manufacturing process of a nature, right, is a uh, whole part as a whole, right? And then naturally it grows and comes to the required or defined shape and size, right, depending on the habits and all these things, right? So the what we have to conclude here is that natural manufacturing process is not a assembly process, right? So which is a our conventional manufacturing process, right? So the another important aspect is that whenever the natural manufactures something, there is no wastage, right? So as in case of manufacture subtractive manufacturing, right? So it is almost a zero waste, right? So in case of what you call plants and likewise, or in another, depending on the type of element it is, right? So over a period there might be some what do you call deletions and additions and likewise, but the wastage, right, is almost zero, right, in case of nature's manufacturing, whereas in case of conventional we do have a lot of subtractive manufacturing, right? We have a lot of waste that is generated, right? So this is the another important correct. First is that assembly is not the natural process. The second is there is no wastage as far as the natural manufacturing is concerned, right? So this 3D printing, right, is one of the emerging technology which is inspired by the nature, right? So in this figure and in the next figure as well, right, what I will do is I will try to explain you what is basically the 3D manufacturing process, right? So what we do is, in case of a 3D printing or additive manufacturing, we prepare the 3D CAD model, right, using any of the software, right? And we will have that particular data of either in the form of IGS files, step files, and likewise, right? Whenever you prepare a model using some modeling software, that particular data is generated, right? So first thing you need to do is to have the CAD model. When the CAD model is there, right? So in case of additive manufacturing, here you can see it is placed or the manufacturing process is by adding layer over layer and likewise, right? So in order to get this particular coordinates of the printing, this particular file, we slice in the form of layers, right? And there we are getting, if we use the STL file, right, dot stl, that is the dot stereolithography file, then this particular slicing software slice that particular object and converts that into a dot stl file. That stl file which will be sent to this particular 3D printer, which will be that data, right? In CNC, what we do is we give that particular coordinate values for to be followed the G code, right? So for example, G01, X something coordinate, Y something coordinate, and then we control the tool movement, right? So similarly here, the data which is generated from that particular STL file. So what we do is we prepare a CAD model, save it is in the STL file, which will be providing the coordinate values, and then there will be an interface of this particular data with the 3D printer, which will be using that data, will prepare the coordinates of each of the layer depending on the shape and size. Right. So these are the various names, right? So initially I was referring to, right? So this additive manufacturing, then 3D printing, all these are the synonyms names, right? So in earlier days, this 3D printing or additive manufacturing was used, the name used was rapid prototyping, because it was used for that purpose, right? For preparing the prototypes. Then the stereolithography SLS, right? So that was used based on the principle, right? So basically it is used for plastic and that material, right? The another name is 3D printing, right? Actually, depending on what it can do. Then additive manufacturing is another name based on how does it do, right? So we do it on adding the material, right? So that is the another name given to this particular 3D printing. It is also called as a layered manufacturing, because we go on placing one layer over the another one, right? So is a layered manufacturing. The another name is solid free form fabrication, right? So free form is basically we don't require any die, sponge, or those kind of things, right? For manufacturing or fabrication of that particular components. Then another one is direct digital manufacturing, right? So earlier we have referred from art to part, right? So is a kind of a direct digital manufacturing, right? So these are the various names by which 3D printing or additive manufacturing is recognized as, right? But the basic remains same, right? So it's basically layer by layer manufacturing, and for that we can use any material, and the basic process remains same, right? So okay. So, as we are talking, in the afternoon, we will have a detailed session on what are the different additive manufacturing processes, right? So, basically, these particular processes depends on the material, right, which is used for this particular manufacturing. Okay. So, you can have the material which is in the liquid form, powder form, or solid. Okay. So for liquid, we'll be using a stereolithography, a jetting system, and direct light processing. Right. So basically, if it is in the form of plastic and likewise, right. So to get it solidify, basically what we require is polymerization when it is exposed to light. Right. So you can control the solidification by controlling the portion of or the area where the light has to be focused, right? So these are the liquid based processes. Then in case of a powder based, right? So we can have selective laser sintering, three-dimensional printing, fused model deposit system, electron beam, right? So here if you look at what actually it is in case of a liquid base, right? For example, I have said you have to control the area which is exposed to the light, so that it get polymerized and thereby get solidified, right? So in case of a powder base, what we will have a powder of the material, right? And what will happen is basically we need to control, right? So if it is a powder form, and if that has to be uh, what do you call taken together, right? So it has to be first fused, right? And for fusing of that particular material, we have to use some heat source, right? Basically powder will be for the metals, right? Metals okay. So it has to be fused, right? And it requires a heat, right? So here depending on the heat source, here you can see, here we are using a laser, right? This is a fused metal, right? So there will be some heaters, and likewise you can see the electron beam is used, right? So these are based on basically the resource which is used for as a source of heat in order to sinter, right? So here in sintering, right? So in composite materials, that sintering process is used, right? So deposit and compaction and likewise, right? But in another process, the compaction and all these things will not be used. The powder will be fused in the required portion for that particular layer, and accordingly the component will be formed, right? And if you look at the bottom side processes, right? So selective masking, selective inhibition, centering, right? So in this case, what we do is basically we are controlling that particular portion, right? So in masking, centering, right? So what we do is you mask the unwanted material, and only required material is exposed to that particular heat source, right? So thereby it melts in the required shape, right, for a given layer, right? So these are the various processes which are for used for powder based additive manufacturing, right? And in case of solid based, we have fused deposition modeling. In fused deposition, right? So if you look at the name, what we get is we have a solid material, right? Then it is fused, and that right, in case of jalebi making, we have seen we have a batter, right? And the battery is in the form of fused, right? The battery is in the what do you call semi-solid, and likewise which can be injected through that particular hole in that case, right? Or in this case it will be a nozzle, right? So we will have some mechanism which will be used for fusing that particular material, and the nozzle will be controlled in order to get the required shape and size, right? So these are the basically additive manufacturing processes based on what type of raw material we are using, right? Whether it is a liquid based, powder based, or solid based. Okay. Prasad sir, I'm audible and everything is fine, right?
Yes, sir.
Yes,
You're
sir.
audible.
You are audible.
Okay. Just taking the feedback. Otherwise, it will be a slow session, right? It should not happen like that. Okay.
Everything
Okay.
is fine, sir.
Fine. Okay. So as far as 3D printing is concerned, right? So initial days are in the 1980s, and likewise, where this particular rapid prototyping technologies, right, has been introduced, and the credit goes to Mr. Charles Hull, right, who has invented this particular stereolithography process, right, which virtually have turned into a good and appreciated manufacturing processes, right? So just to this was the earlier what do you call earlier days, right, of maturing that particular technology, right? But if you look at here, right, so the market, right, has raised to $10,000 dollars, right, for the first system, and the Stratasys and all these particular companies, right, they have introduced the printers, right? So you have now the printers which can print anything, right? Anything means literally anything. I will uh, uh, show some example to you in the due course of time. Okay, so this is what the 3D printing process, which already I have explained, right? So here, what we have to get that particular 3D CAD model, right? Again, for modeling, there will be some 2-3 processes, right? So either you can start from the scratch, building that particular 3D CAD model, or you can have the 3D scanners, and likewise. Just one second, please, Manoj. Manoj, 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 मनोज मयूरचा फोन आला होता, त्याला फोन करून घे. मयूर मयूर हा.
एक कॉम्प्युटर पाहिलं होतं तिचं इन्स्टॉलेशनसाठी. मॅडमला मी बोललो, मॅडम बोलली सांग
घेऊन टाक प्रोसेस, किंवा मग हे तांबेकरांना म्हणा लॅपटॉप असेल ते लॅपटॉप.
लॅपटॉप मशीनवरच येईल, कारण ते इन्स्टॉल करतील फाईल्स.
हा
मशीन समजा लगेच आपल्याला नाही आलं तर ते सध्या पुरतं ठेवतील.
हा ठीक आहे, पण मग सॉफ्टवेअर घेऊन ठेवा तुमचं.
हा सॉफ्टवेअर.
Sorry, actually one installation is going on, so fine. So what we have a 3D card model which we can build in our conventional modeling softwares like SolidWorks, CATIA, or likewise, right? Or you can have that particular data by 3D scanners, and you can repair it and get it done. Okay, so after modeling, this is STL, right? So here you can see all the it is discretized, right, divided into small portions, right, basically layers, and in the form of triangular elements, and likewise, right? So basically to get all the data, so directly whenever you create the model, right, you have to save, say for example, dot part and that kind of file, right? So similarly, if you go on file save as, right, so you will have a number of options available in what particular format you have to save, you want to save that particular data of the CAD model which you have created. So it could be in a neutral file formats like IGS, or a step format, and likewise, or .stl file is another option. If you have to use that particular model for 3D printing, you have to use this particular option to save those files, right? So once this particular .stl files are created, that will be sent to the slicing softwares, right? So Cura is one of the famous slicing software, right? So what it basically what we require is we require data, right, layer by layer. So here you can see this is a product is .stl file, and the manufacturing will be layer by layer, right? So in order to what do you call, lay this particular layer on the downstream layers, you need to control the nozzle as per the shape, size, and coordinate values, right? So we'll have slicing software, right? And through that, we will have the number of layers, right? So all these particular parameters to you can control, right? So you can control what should be the layer thickness, right? The overlap and all these things, right? So there will be a demonstration on this by Pushkar Suryavanshi sir. We'll be talking about this how this layer slices, the parameters, the temperature, right? Nozzle temperature, bed temperature. Then there will be number of parameters which can control the quality, time, and all these things, right, of the component which is 3D printed. Then this particular layer and tool path is given to the 3D printer. It will have X, Y, Z, and all these things. I will show it to you, and then we will have the 3D object, right? So here from CAD model to 3D, right? From art directly to part, right? Without any conventional machines. This is what the process of 3D printing. Okay, so this is another right. So way, as mentioned earlier, we can use a CAD model to model that particular component from the scratch, or if some components are existing, right? So, for example, in many cases, right? So, if you look at the components, the say, spares and likewise, which are not available, and you have to manufacture it, or in case of these 3D scanners are basically are more useful for medical applications, right? Particularly implant and all this, right? So for that, we used to have the 3D scanner in CAD model. That particular data of 3D scanner will be taken and repair some if required, and you will get that particular model, and directly you can print that particular joint. Implant, right? Joint means the, actually I was referring to a knee joint, right? So what happens is basically all the human being is physics is different, right? And so you cannot have off the shelf, right? Knee joints and likewise, right? For biocompatibility and the compatibility with the dimensions of the bones, joints, and likewise, you need customized joints, right? So we can have the 3D scanner of the actual dimensions, get it done, printed, and to your required shape and size, which is more suitable for that particular implantation. Okay, you can have this thing, right? So in that case, either for rare part or the part is available, you can scan it and can develop that particular model, or for implants and other critical parts, you can use 3D scanners, right? So this is another method of creating the 3D model from object. Okay, the same is the depiction, right? So we have CAD design, we have STL file formats, the slicing of it, and here this is the slicing. Here you can see that the layer by layer deposition is there in case of 3D printing, right? So again, another type of reflection, right? Way of showing how this particular 3D printing works, right? So object is created, slicing .stl, then slicing, then you have to provide the printing parameters and actual printing, right? So this is what the overall process. Okay, so basically, let me show you how this particular 3D printer construction, right? So in the beginning, I was referring to the CNC machine, right? So 3D printer is basically a CNC machine, right? So what you need to do is you need to control in CNC, you have to control the tool path, right? Means you have to control the movements in X, Y, Z direction of that of the cutting tool, right? So here you have to control the movements of the nozzle, or in case of say centering process, you have to control where the layers are guided and likewise, right? So here we have three axes, right? We have X, Y, Z, right? So this is Z axis. We will have Z motor, and there will be electronics to control this particular X, Y, Z, right? So basically, say if there will be three axes, three motors, three lead screws, and there will be a machine control unit which will be controlling this particular simultaneous movement of the nozzle, right? So here you can see the timing belts and all these things, right? So if you have seen the CNC machine, or you can have the what you call simple 3D printers, right? So basic thought is same, right? You have to control the tool, means nozzle means you have to control the movements in three directions, X, Y, Z directions, and then accordingly you need those particular control electronics for controlling the movement, right? So you can XYZ, right? So along with that, there will be some accessories or necessary functions, right? So you have to control the temperature of the nozzle, you have to control the temperature of the bed, you have to feed those particular material to the nozzle, right? You have to transfer the files from either directly computers to the 3D printer, or you can have the SD card, right, where the data will be directly instead of having it in network, you can directly transfer that particular file to the 3D printer and likewise, right? And as far as 3D printer is concerned, let me tell you that these are available as cheap as 10,000, right? To if you go to metal additive machines of, for example, that of Renisho and likewise, they are up to 15 crores and likewise, right? So depending on the quality, reliability, and the type of material you have to print, right? Uh, there will be a variety of printers that are available. Okay, in Amrutwaini, we do have a plastic printers, right, of different technologies, as mentioned earlier. We have four, right? One is with zero point 0.5, zero point 0.5 into zero point 0.6, right? So that big volume of printer you can have, right? And as small as it will be 15 centimeter by. I'm talking about the volume, right? So basically, this will be the volume, right, where you will be printing, right? So this is the platform, or this is called as a bed. Okay, so in many cases you have to also provide the temperature control of this particular bed and the nozzle, right? So deposition and this one, right? So that what will happen is if the that particular control of heating is also required in that case. So from right, so one layer has to be get what you call a proper bonding with the earlier layer, right? So there are a number of things that goes into that has to be considered while you actually going for 3D printing, right? So basically overall this is what the structure is, right? In case of a metal additive manufacturing, right? So see what will happen is when that particular either you are diffusing, or you are melting that particular powder, right? So what will happen is basically there will be chances of heating, right? So temperature will increase, then oxidation and all these things, right? So in that case, you have to have this particular environment as a controlled environment, right? So as to avoid the oxidation, and then in that case, that will be that metal additive printing will be done in the inert gas environment, right? So you will be using argon or helium or that kind of gases, right? Inert gases, so as to avoid oxygen. And once the control environment is there, then again you have to have more control on that, right? So flow, the content, and the control system, then fumes will be there, that has to be done, and right. So as the system gets one more component, the controlling of it, and associated circuits and accessories that will be required, right? So all these things will depend on what has to be printed and what are the requirements of that printing, right? But basically all the 3D printers will be like this. Okay, So more important is we need to understand, right, what has to be, what can be printed, right? So here you name the material, right? You are able to print. Okay. So if you look at, we can use for printing of the plastic components. Milling sir is visible and everything is fine, right?
Yes, sir. Yes, sir.
Okay, right.
Yes.
So you can use this plastic for 3D printing. You can use metals, right? The metals can be 3D printed. You can see here, right? You have the compound materials, right? Either it could be a composite material or compound, right? So this is ball in ball, right? So basically, if you are using the conventional material, right, so that is not possible in this case, right, but here you can use the compound materials for printing. Here you can the ceramic, right, which is very difficult for conventional manufacturing, right, so that could be also in right. Most of the time we use powder metallurgy and those kind of manufacturing processes, right? So here the ceramic also can be 3D printed. You can print the resins, right? You can print the chocolate, right? So what you need to do is, see, the basic is, if you look at, right, for chocolate, fusing, right? So it is same as the batter of jalebi or your mainly kind of thing, right? So if you melt it and then if you look at dairy milk and all these things, right? So what they do, they have the in a molten form and then pour it in a mold and accordingly the shape size, right? So same is the case, right? So you can manufacture the chocolates, right? The papers, right? So this is a paper product made of papers, right? Layer by layer, you can see that is also possible. And the sand and all this, right, which is a part of a ceramic, right, you can have this one, right, can be printed, right. So printing techniques will be different, right, but you name the material, we can have this particular this one, right. And material, right, so if you look at metal, right, so as simple as materials like aluminium to say titanium and likewise, right, so that range of materials, right, also can be printed, right? So that type of metal printers are available, right? So why I said titanium or likewise, it is very hard to machine, the very high temperature required for diffusing that powder and likewise, right? So it's got a horizon, right? And remember one more thing, it's not only material, right? It could be we will have some examples of it, right? Whatever you can model, right, that can be printed. Basically if you look at the conventional manufacturing, the odd size or some asymmetric kind of material component that is required and that has to be printed, probably it is not possible for you to manufacture that, but in case of additive manufacturing, that is possible, that you can print whatever you, if you are able to model, you are able to print, right? Whatever the material, you are able to print, right? So this is a power of additive manufacturing or 3D printing. Okay, so this categorization of manufacturing processes already we have addressed, right? So in the afternoon session, Professor Ravi Gite will be detailing on all these particular processes, right? So based on powder, liquid, and solid, and likewise, right? So for powder, you can see SLS is there, right? In case of solid, you have binding and laminated, right? So laminated object manufacturing is your layer, right? One lamina is one layer or one sheet, right, is one layer, right? So accordingly you can do that, right? Here you can have photo masking and likewise, right? So this particular this is the classification of layered manufacturing or additive manufacturing, depending on what type of raw material, right, whether it is in powder form, liquid form, or solid form, you have to use the corresponding method for manufacturing. Okay, so in here, this is the for stereolithography, right? So here you can see that here is a laser beam, right? So here basically this is the what you call uh, tank wherein there will be racing, right? So what will happen is the Z direction will be controlled by this one, and the XY will be controlled by this laser, right? So what you have to do is you have to focus this particular laser. If you look at XY, right? So XY will be providing you the shape and size of that particular layer, right? So depending on whatever is exposed on this particular table, right, that will be cured by using laser beam. So what will happen for next layer to happen? This will come one down layer, down equal to the thickness of one layer. The additional resin will be there, and it will be cured, and likewise, right? So likewise layers of solidified resin, right? So this is first one, second one, and likewise, right? So if this is to be what do you call cured or solidified, this particular laser will be focused on this particular area, this area. This is Z, right? On the XY you can have any of the geometry of that particular layer, right? So this is what is basically the SLS does. Right. So this is for digital light processing. Right. So this is for photopolymerization. In earlier case, the laser was used as a source. Here, the process of solidifying is photopolymerization. So accordingly, that will be focused. Right. So here you can see we have deformable mirror device called DMD. Right. So what it will do? That particular there will be some of photo source, right? You will have a lenses to adjust the intensity, and there will be one controlling mechanism which will guide the focusing of that particular lights, right? So this is the digital light processing kind of technique, right? This is the laser centering, right? In laser centering here, if you can see, right? So this is the table XYZ, right? Here we have a laser Nd:YAG or whatever is depending on the power required to melt that particular powder, right? You have to decide that. And here you have XY scanning mirror, right? So Z will be through this particular the thickness, right, will be provided through this particular Z axis, and here you can see XY. So this is what the shape and size of the layer is, right? So what we will do is we will control this particular mirror, and accordingly it will go on like this, right? Solidifying, and likewise, right? So what is to be solidified, what is not to be solidified, that will be decided by this mirror XY, which is controlling the XY, right? As in case of CNC we have. Okay, so this is process of additive manufacturing, right? This is the fuse deposition model, right? So here you can see we have a spool of plastic material. It could be ABS or PLA, whatever, right? So it could be one nozzle, multi nozzles, and likewise, right? So basically, what we have a mechanism for feeding that particular wire to nozzle. So here nozzle we will have heaters, right? So here we have a solid plastic, and heater it will fuse that particular material, and then will be extruded through this nozzle in order to print this particular part, right? So as here the material is deposited in the form of fused material, so is called as a fused deposition modeling, right? So this is basically a FDM kind of a method of 3D printing, right? This is a laminated object, right? So here you can see this is a sheet material, right? So if we require only this one, so we will have a laser which will cut this particular material in the given form, right? Then will be taken up next layer, then again it will be cut, and likewise, right? So this is the layered manufacturing, right? So here in order to have the binding of this particular layers in between, we can use the binders or additives in that kit, right? So this is the laminated, right? One lamina or another lamina. One lamina is cut in that required shape, placed on another lamina, some additives, and likewise, right? So basically what this furniture people are doing, right? So they cut in required shape, right? So ply upper ply upper ply, and then we will have a final laminate and likewise, and that is placed on the furniture you want to, right? So that is the kind of layered manufacture. Okay, this is the ballistic particle, right? What we do is here is basically for ceramic or sand and likewise, right? So what we do is here, if say this is the sand and likewise, right? Then in order to get that particular, in the beginning, I have shown the statue of idol of Lord Ganesha, right? So basically, it using a sand, right? So what you need to do is we need to provide that particular binder so that only the required portion of that particular sand is hold together, and the remaining, once you make it top down, right, the remaining will get out of that particular uh, adder. Okay, so here this is also called as a binder jetting or likewise, right? So binder or additives are dropped as per your material, right? And this is what the support, right? So we will come to that particular design aspects as well, right? So we need to have the support structure in order to build the required component. Okay, so this is the ballistic particle manufacturing process. Okay, this is the laminated, right, as shown earlier, right? So this is the view. Okay, so layer by layer, right, and they are cut and the material is going like this, right? So here you can see that is kind of a blanking process, right? So whatever the blank is required to be placed here, that will be cut through laser, the next blank and likewise, right? So this is the layered laminated object manufacturing, right? So this is the example of a binder jetting, which, right? So this, what we are doing is we are putting the binder, right? So here you can see this particular ceramic cup is the product, right? So in order to get that one, what we are doing is layer by layer we are putting the binder in the areas where it is required, and another will be material or powder will be taken off once it is printed. Okay, so these are the in nutshell what are the different technologies that are used for additive manufacturing. In detail, we will have a session in the afternoon by Professor Ravi Gite. Okay, so as mentioned earlier, this is a disruptive technology, right? So why it is called disruptive technology is basically it has wholly changed the way the manufacturing is done. Right. So earlier we have conventional systems, right? Big shop floors, all the different types of machines, right? You require lathe machine, you require milling, slotting, this, that, and all these things, right? So all these machines are replaced or are not required if you go use this additive manufacturing, right? So as it has changed all these things, right? So has brought in the disruption in the manufacturing technology, the way of producing the components, and so by this 3D printing is called as one of the biggest disruptive technologies in the field of manufacturing, right? So here, why this particular manufacturing 3D printing or additive manufacturing is required, right? So if you look at the advantages, right? So we have the objects, right, in which we require either direct assemblies or non-linear ducts. I will show the example of all these things in the due course of time. So we require direct assembly in this case, right, or in this case, right? So these are the examples of direct assemblies, right? If you look at the non-linear ducts, right, particularly if you consider the cooling of conformal cooling of some thermal systems or likewise, there you require the inside ducts, right? So that you can provide the cooling material and likewise, which is not that easy to manufacture with the conventional manufacturing process, right? But that is possible with these. Okay, so here you can see in this component, right? So this is kind of a cup where you need to take away the heat, right? So there will be a cooling channels inside and all these things, right? So that is pretty difficult in case of a conventional, right? So there are some difficult to manufacture components, right? So if you look at this is a kind of here you can see that there are turbine blades and likewise, right? So uh, is a kind of a slender manufacturing, right? So where thickness is very less and the dimensions are bigger, right? So if at all you want to machine such components, right? So for example, turbine blades and likewise, right? So it is very difficult in that case, right? That manufacturing is very difficult, but can be very easily done by using this particular additive manufacturing, right? So optimal light and lattice structure and likewise, right? So you can see here, right? This is the lattice structure, right? All these components, right? So these are the lattice structure. So there are requirements that weight has to be minimized, right? For example, either it is the aerospace applications or likewise applications, or say knee joints or some implants, right? So you need to reduce that particular weight, right? As much as you can. Okay, so that particular lattice structure, or though here you can see this is a one structure, right? So manufacturing this particular structure, right, you can do with the casting or likewise, but again will be very difficult, right? The dimensional control, then you require post machining and all these things, right? But in case of by using 3D printing, it is very much possible to have this kind of components, right? And particularly nowadays, the area, right, or where the additive manufacturing is in demand is in biomedical applications, right? So here you can see this is the knee joint, right, which can be very easily, right, as per the requirement of the dimensions of that particular patient, you can manufacture this particular 3D printed components, right? So this is how, right? So you can produce the state of art customized products by using this additive manufacturing, right? So as mentioned earlier, anything that can be modeled can be printed, right? So any material, anything that can be modeled can be printed, right? So this is what the power of additive manufacturing is, and so why it is called as disruptive manufacturing. Okay, so to more this one, right? So this is for direct assemblies, right? So here we will have 1, 2, 3, right? So these are the parts, right? So in conventional, that has to be what you call manufactured separately and then assembly and all these things, right? So digital screen they are launching now. So you can see, right? So these are the three components of this one, right? So it is very important.
Wakchaure sir, please
Wakchaure sir,
unmute your mic.
unmute your mic.
Hello. Sir,
Hello?
please unmute your
Sir,
mic.
please unmute your mic.
Sir, unmute your mic.
Sir, unmute your mic.
हॅलो.
Yes sir, please.
Yes, sir, please.
हा, मी ऑडिबल नव्हतो केव्हापासून?
नाही सर, आत्ता झालं
नाही सर,
होतं.
आत्ता झालं होतं.
आता झालं होतं ना?
हो
ठीक.
हो सर. ओके
हो
सर.
सर, ओके सर.
स्क्रीन विजिबल आहे?
Yes sir.
Yes, sir. Yes,
Yes,
sir.
sir.
प्रेझेंटेशन विजिबल, राईट?
Yes sir.
Yes, sir.
Yes, sir.
हे स्पॅनरचं वगैरे बोललो ते ऐकलं ना?
Yes sir.
Yes,
Yes,
sir.
sir. Yes, sir.
Okay, fine. So similar is the case with this particular turbine casing, right? So you can see this is the casing, blades, and likewise, right? So these are the components, right? So here thin wall turbine, right? Again, thin wall manufacturing is again difficult. Then assembly of this thin to the casing and likewise, right? So through this additive manufacturing, here you can have a single product, right? Direct assemblies as far by using the additive manufacturing. right? So this is another, right? We have when the geometric complexities are there, right? So here you can see these are some of the inlet manifolds or components, right, where you require some burners and likewise, right? So here what you require is you require the internal coolings, right? So these are the internal cooling lines, right? You can see in green, blue, orange, and magenta, and likewise, right? So having this kind of components and those particular cooling channels, right, non-linear ducts inside that particular manufacturing components, right? Conventionally, if you look at this shape and size, right, so basically it's very difficult to get this one, right? So these are the nozzles, right, of which are connected to the exhaust system or the manifold or injection. Okay, so in that case, getting those particular whole pins through this one is very difficult through conventional manufacturing, right? So for this, we are using the 3D printers. Okay, customized solutions, right? Particularly, remember that biomedical engineering is one of the biggest customer of a 3D printer, right? So here we can have the, right, whatever you name, right? So it could be some bone parts or joints, right, or even the teeth, right, or some kind of a spongy mass or that kind of thing, or the राइट ते आपलं खाली जम हे असतं ना दाताच्या खाली, राईट, तो पर्टिक्युलर पोर्शन, you name it, right? So all these particular things can be printed, right? Now the another beauty with the medical thing is that you cannot have a standard component shape and size and all this, right? So it keeps on changing as the patient change, right? So what you require is you have to customize that particular uh, implants, right, medical implants, as per the requirement of your customer, right? So for that, you can use this particular 3D printing, right? So in Pune, there had been many, right? Sancheti is right. Why I am named Sancheti is because it is one of the major accident hospital, right, in Pune. So they have their own what do you call plant for preparing this particular implants, right, for patients. Okay, so this is for optimized lattice and lattice structure, right? So here this is what you can see, one bracket you can see, right? So instead of the forged or another conventional type of bracket where weight is the more constraint, okay, you can use OptiStruct, right? OptiStruct is a kind of a software like your ANSYS or likewise, which is used for optimization of structures, right? So that is what the OptiStruct is, right? So here, if you are optimized, right? So there are two things. Designing is something different, and manufacturing according to design is very challenging, right? But here, if you design this one, right? So once you have the FE analysis and all these things, right? So you have removed this material because the stresses are not are less, and so why you are removing that material and likewise, right? But manufacturing according to the design will be very difficult and challenging, right? So in that case, we will have this particular 3D printing will help you, right? So this is what the honeycomb structure or the lattice structure, right? So in order to reduce the weight of those particular components, right? So this is a simple head and right, a simple screw kind of thing, right? But here you can reduce the weight of those particular screws or brackets or even your helmets and likewise, right? So whenever you require optimized lightweight or the lattice structure kind of components, you can use 3D printing or additive manufacturing, right? So this is what the non-equilibrium matrix, right? So the components are not symmetric, right? So in that case, right, you can use for components having more complexities, right, to manufacture, you can use this particular 3D printing as one of the technology, right, and a more potential technology, right? We will go to what happens to the strength and all these things later on. Okay, so these are the state of arts components we can manufacture, right? So this is for conformal cooling and direct holes in that one, right? So all these things we have discussed, right? Okay, so you can see these are kind of the complex structures that has to be built, and that is possible through this additive manufacturing itself, right? So this is another typical example, right? So I had been to this big M manufacturing. This is a kind of exhibition which happens with ASL conferences and likewise, right? So the whole what do you call the products, right? From car to your simple toothbrush and chocolate, right? So that kind of all products we are displayed through this which are printed, right, or which are additively manufactured, right? So here you can see this is the 3D printed electric motorbike, right, having only 35 kg, right? So if you take conventional, it is minimum 200 kg weight, right? So this is only 35 kg, right? So whole body is looking at cheese, right? So that kind of structures you have, right? And strength and all these things, right? So that could be taken care during the processing and post processing, right? So these are the two important aspects. I will talk about that, but here uh, you can have these bikes through this one, right? So actually I was talking about the implant and likewise, right? So this is for a skull, right? If the skull is fractured and likewise, right, this is for your face and likewise, right? So whatever is the kind of portion that is required, that can be printed by using additive manufacturing. Okay, so here you can see, right? So here having this kind of a light in order to, earlier it was only screw and likewise, right? But over a period the things okay, नंतर तो दुखतो वगैरे असं काय होतं because not having a proper joint and likewise, right? So here you can have the anchor architecture for that particular stage which is for connecting these things, right? So here you can see, right, the plastic plaster, right? This is a customized one, everything, right? Plaster is for providing or restricting the movements, right, for the bones which has got fractured, right? Now instead of having the itching and carrying all these things, right, what we can have, we can have a printed what you call a structure which will be used by that particular patient, and there will be no itching, no heaviness, and all these things, right? So these are kind of innovative products you can manufacture by using additive manufacturing, right? So this is another bicycle which is printed by using this one, right? So here this is what the skull actually I was talking about, right? So here probably there had been some accident, there had been fracture in the skull, right? So you can have the 3D printed skull and can be directly used in the patients, right? So likewise the things are being done to a large extent using this additive manufacturing, right? So these were the some applications of this particular additive manufacturing, right? So if you look at the how this particular, these are the very old figure, right? So for 2012, after 13 years it has been at least 4 or 5 times that of this particular figures projected in this, right? So this is shown just to make you aware that if you name the field, right, where the additive manufacturing can be used, right? So it can be used for consumer products in electronics, right, automotive, then medical applications, aerospace application, tools, molds, and likewise even though in entertainment and likewise, right? So there are a lot of verticals, right, areas, domains where now additive manufacturing has started replacing our conventional manufactured products, right? because of many reasons, right? Because of the cost, because of the design, because of the kind of product that is required, right? Customization, right? So all these things is possible with the additive manufacturing. And so now there are some products which are continuously manufactured using additive manufacturing only, right? Because what had happened is that large volume is not there nowadays, right? And in order to cater to the needs of mass customization to a somewhat higher side, most of the components are uh, they are replacing the process with additive manufacturing, right? So here there are some advantages, right? So let me talk about the customization, right? So we have a conventional, and red is a additive manufacturing, and Y is sorry, the black one shows your conventional, right? So customization, you can see that if you look at from customization point of view, the additive manufacturing, right, as mentioned earlier, whatever you can model, you can train, right? So it gives the flexibility in customizing the products. As far as the intricate parts are concerned, the complex parts can be printed more conveniently, more effectively by using additive manufacturing process, right? The prototyping cost in case of additive manufacturing, right, it is very less as compared to conventional manufacturing, right? So you know that in conventional manufacturing you require a lot of testing and trials and likewise, which is not required in additive manufacturing, right? And so why the lead time, right? So that is from model to part is very less in case of additive manufacturing. The cost, right, as this is a customization, right, as per the requirement of customer. So why, as the number of units, right, so that goes without saying, right? So if the quantity is less, the unit production cost will be somewhat higher. But as the technology will go on maturing, things will become more cheaper, right? Now the important two aspects, right? So that is the strength and surface finish, right? So by virtue or by nature of this particular manufacturing process, you can see that it is layer by layer manufacturing, and use some fusing or laser metering, and likewise the if you compare the same part which is made up by the additive manufacturing process and another by your conventional manufacturing process, it is very obvious that the strength of your component which is conventionally manufactured will be on a higher side, right? But having said this, there are number of methodologies, right? Because see what will happen when you print, melt, and all these things, right? So there will be some residual stresses that will be there, right? Then how effective the bonding, right? I talked about the printing parameters, right? So what are the printing parameters, right? What is the powder, but what is the form of powder, what is the shape and size of the powder particles, right? What are the printing parameters? Okay, so all these things, parameters will decide the strength of that particular component, right? But if you choose it more properly and you have appropriate post processing, right, means once it's printed, you have some kind of residual stress removed techniques you can use, like a cryogenic and some kind of heat treatments, right? You can regain the strength, right? But in that case, you require to improve the strength, you require to select a proper raw material, proper machine, proper machining parameters, and then some kind of post processing that is required for additive manufacturing. As far as the surface finish is concerned, yes, as this is made of grains, and likewise the you require post processing for removing the support structure and all these, right, which is used for printing the material. And then as this is made of what you call powder and likewise, right? So surface finish will be issue, and again, as mentioned earlier, you can have some post processing, right? But the post processing required will be very minimal in this case. But if it is required, then what is the extent of that surface finish requirement? That will be depend on again the powder, the machine, then processing parameters, the thickness of layer, right? So if the thickness of layer is high, then obviously, right, your surface finish will not be that good, right? If you go small layers, the thickness, the surface finish will be very good, right? But again, you have to compromise on the speed of manufacturing and likewise, right? So you have to have a proper mix, right, of what do you call parameters, right? And what are your printing parameters, or as such, depending on what are your strengths required, what is surface finish and the type of structure, and likewise, you have to decide the parameters, printing parameters for this particular 3D printed components. Okay, so this is some benefits and applications were already to some extent we have covered, right? So there are many design iterations within limited time that is possible, right? So here you can see all these quadcopters, right? In Amrutvani also, the students are using this particular 3D printing facilities for various hackathons, right? Then for SAE, PAHA competition, PIFAN competition, likewise for PBL, project-based learning, and likewise, right? So quadcopter and all these things are again one of them, right? So here you can provide this particular facility, use this particular facilities for various purposes, right? So from innovative products to your student projects and likewise, right? So these are a few of the cases where you can use additive manufacturing, right? A gas turbine already we have talked about, right? So these are the kind of tooling and where we can where the machining is difficult and you can use 3D printers for that purpose, right? So this is for maintenance, right? So one of the blade was corroded and you require another blade, right? But it is very difficult to get, and you have to replace the whole rotor, right? And the cost of rotor is very high, right? So in that case, what you can do is you can scan the individual blade, manufacture it, right, and get it fitted, right? So for maintenance purpose also, for spares and likewise, you can use additive manufacturing. Okay, so this is one like quadcopter, right? You can use it for manufacturing the various parts, right, of your projects, and likewise 3D printer can be used, right? So for SAE, right, so in our case, the student has used it for machine for preparing various components of robots, then in-tech manifold of the ACA competitions and likewise, right? So you can encourage the students, right, for participating in different, right? Even though your whatever the setups are required for your research work, that can be also printed using this particular additive manufacturing technology, right? So these are the few simple components, right? The models, the prosthetics, right? Implants, surgical devices, right? All these things you can prepare by using additive manufacturing or rapid technology or 3D printing, right? Whatever you call, right? But whatever you call is a very what you call a technology of usefulness from medical particularly, right? So there are limitations, right? So as discussed earlier, we have talked about the surface finish, right? So here you can see these are the kind of a support structure that are required, right, for printing. But you need to provide, remove this particular support structure, right? So the post processing is required, right? The post processing is required, right? So actually, I was talking about the thickness of layer, right? So here, this is the actual model and this is the AM part, right? So here you can see you have the staircase effect here. But if as you go on reducing the thickness of each of the layer that is printed, you will be able to control that particular surface finish, right? Okay, poor internal quality. Now, this is because pure internal quality, that means to say there will be some porosity issues will be there, or probably the density may be varied and likewise, right? So, that will basically you can control with the proper support structure and using proper manufacturing or printing parameters, right? You can get those things taken care in the initially, right? So that is uh, inherent limitation, but that can be controlled if you select the proper printing parameters, right? So this is what the overall about additive manufacturing, right? We have talked upon what it is, subtractive, then additive, what are the different methods, their applications, their limitations, advantages, and how this particular additive manufacturing technology is kind of a disruptive technology, right? And is we people we need to propagate this particular technologies, right, among the students so that they will be industry ready. So that's all from my side. Now, if you have some questions or like is, please.
All participants, if you have any question, query, please ask. Participants, any questions, any query असतील विचारू शकता.
I hope the session was informative and right. So those particularly who are newcomers probably have understood what is this 3D printing technology. I think there are no questions. If at all, I have Milit sir, and they have my contact details. Right? If someone want to visit our 3D printing lab, you are always welcome. My three research scholars are working on 3D printing, particularly in metal additive, aluminum alloy. Then another scholar is working on titanium alloy, and one scholar is working on now 4D printing, right? So 3D printing is there, but one of the scholar is working on 4D printing, right? So there, time is the another dimension which we have considered, right? So that's how the technology is progressing, right?
Before moving to voter thank instruction, our second session scheduled from 2 p.m. to 4 p.m. Mr. Gite sir join me for 5 minutes of session. We have Sir Dr. M.S. Gosai Polytechnic and Mechanical Department. I extend my heartfelt gratitude.
Amit sir, if you want to continue and the time is there, we can, right? If the participants want. Actually, I have spared this 15 20
Yes, sir.
minutes
Yes,
for
sir.
other
No
questions.
Yes, sir.
problem.
Yes, sir. No problem. Sir.
Yes, sir. You can. Yes, sir.
You
Yes.
can. Yes, sir. Yes.
Okay, please go ahead.
Okay, sir.
Okay, sir.
Sir, continue करा.
Sir, continue करा.
Acha. But it is better to have some question answers, right? So, Zuman sir.
Yes, sir.
Yes, sir. How are you?
Yes, sir. Thanks.
Any question or something it is required? I'm there, right? till 1 o'clock. Is there any one who is working on additive manufacturing or teaching additive manufacturing? Hello?
I think, sir, we will conclude this session now.
Okay, fine.
If you have any question, please ask.
Yeah, otherwise,
If anyone has a question, otherwise, we can conclude this session. Feedback link will be shared on group, so all are requested to submit feedback. Amit, sir, please conclude this session.
Okay. Moving to our vote of thanks on behalf of Sir Dr. M.S. Gosai Polytechnic and Mechanical Department, I extend my heartfelt gratitude to Dr. Wakchaure sir for valuable insights on first session topic. Thank you, sir.
yes, sir. Thank you
Thank
very
you,
much.
everyone. Thank you, sir.
Yes, sir. Thank you.
Thank you, sir.